This is just a brief overview of how to solve an equation that has a square root in it. The example that's shown, the square root of x equals 4, x should equal the number 16, because the principal square root of 16 equals 4. Mathematically, the way we get that is by using inverses. The inverse of a square root is raising it to the second power, or squaring it. Now, if I want to square the left side of my equation, I must also do that to the right side to keep it balanced. By doing this, I am just left with the value x on the left side. A square root and raising something to the second power are inverse operations. On the right side, if I simplify 4 squared, now I have my answer of 16. So using these inverses, we're going to take a look at the next two examples. Before I try to square both sides to eliminate my square root, I want to make sure that my square root is by itself to start with. As of right now on the left-hand side, I have an additional add 5 on each side. So what I'm going to do is subtract 5 from both sides. And now my square root will be isolated on the left-hand side by itself. I would have the square root of x plus 2 equals the value 10. Now that my square root is by itself, I can apply the inverse operation by raising it to the second power, but I must do that to both sides of my equation. By doing that on the left side, the square root and raising to the second power, those are inverses, they undo each other, so I'm just left with x plus 2. On the right side, I would be left with the value 100. Now I can continue on solving my equation by subtracting 2 from both sides, and I can solve that x equals the value 98. The one below it, I have a coefficient in front of my square root, which means 3 is being multiplied to that. So the first thing I would want to do to isolate my square root is I want to apply the inverse of multiplying by 3. So I'm going to divide the left side by 3, and I need to do that to the right side as well. Now I would have my square root by itself on the left side. Once my square root's by itself, I can apply its inverse by raising it to the second power, but once again, remember you need to do that to both sides. Once I do that, I would just have the value 2x minus 1 would equal my 25 squared. This is a brief look at how to solve an equation that has a square root. The example I'm using is the square root of x equals 4. Mathematically, x should be 16. That's one of our basic perfect squares. The principal square root of 16 equals 4. To demonstrate where that comes from mathematically, we have to consider inverses. Just the same as subtraction is the inverse of addition, multiplying is the inverse of division, raising something to the second power is the inverse of a square root. I can apply the squared on the left side as long as I do that on the right side of the equation to keep it balanced. A square root and raising something to the second power are inverses. That means I would just have an x on the left. And on the right hand side, I would get my 16, which comes from 4 times 4, which is 16. In my next two examples, I'm going to do the same thing. However, I want to take a look at the fact that my square root right now on the top is not isolated or by itself. There's an additional plus 5 that's there. To make this a little bit easier, what I should do is try to get that square root by itself. I can do that by subtracting 5 from both sides of my equation, and then I would have just that square root of x plus 2 on the left. Now that my square root's by itself, I can apply its inverse by raising it to the second power, but I must do that to both sides of the equation. That means on the left side I would only have the expression x plus 2. On the right side that would become 100 because 10 times 10 is 100. Now I can finish solving my equation. In this example I'd be subtracting 2 from both sides, which means x would equal the value 98. The example below it, the additional operation that's happening to the square root is that there's a 3 being multiplied to that square root. So I'm going to apply the inverse of multiplying and divide the left side by 3. That means I must do that on the right side as well to keep my equation balanced. That means my 3's would reduce to be just a 1, so now my square root is by itself on the left, and on the right that would equal the value 5. Now that my square root's isolated, I can apply its inverse, but I must do that on both sides. On the left side, I would only be left with 2x minus 1. On the right side would be 25. And now I can just finish solving this. I would add 1 to each side to begin with. That means 2x equals 26, and last I would have to divide by 2 on both sides, and my solution would be x equals 13. Okay, my last example is to demonstrate what we would do if there's a square root on both sides. In this example, I would just apply its inverse on the left, and I would also do that on the right side. On the left side, when I apply that inverse, my square root and raising to the second power, those are just inverses, they undo each other. That's going to happen on the right side as well, which means I would just be left with that x plus 24. To solve this, I would subtract a 1x from both sides, and then my final solution should be x equals 12.